Hey everybody, it's Kevin Marsh. Welcome to our webinar today. Today we're going to be talking about Infinitii I&I, a revolutionary and new approach to monitoring and understanding collection system wet weather response. Before we get started, just some introductions and housekeeping. I'm joined today by Trent Kamens. Trent, are you there?
Yeah, hey Kevin.
Hey, Trent, why don't you introduce yourself, tell everybody who you are, how long you've been with us, and maybe even tell us where you're calling in from.
Yeah, so my name's Trent. I'm an account manager with FlowWorks. I've been with the company now for just a little bit over 3 years, and I'm calling in from sunny Denver, Colorado.
Oh, good. You got some sun, so a little bit of summer still, right?
Yeah, it's actually supposed to be nice the rest of the week. It's looking good.
Great. All right. And again, I'm Kevin Marsh. And actually, as of today, this will be news to everybody. I've been appointed president of FlowWorks. Up until yesterday, I've been the vice president of sales. I joined FlowWorks about 3 years ago, almost exactly 3 years ago. It was coming up on WEFTech time. And I've been in this industry, I can tell you, for about 30 years, a little bit over 30 years. There's a lot of people on this call who I know, and I've known for many of those. There's a lot of new names on there as well. So hopefully everybody will get something out of this today. Some of you may know me from my days at Marsh McBurney, which was my family's company. We made flow meters, the Flow Tote, FlowDar, really revolutionary products. Eventually, we became part of the Hawk company, and I was there for about 10 years and been involved in different things since then. But I joined FlowWorks, as I say, about 3 years ago because of the commitment that the company was making to investments in advanced analytics and machine learning in this particular space. And so this is, the water, wastewater collection system area is something that I've been involved in, most or all of my career. And to see the investments taking place in this area with this business, it was very exciting to me. And Infinitii I&I is actually the product of that. It's one of the I guess most advanced analytic and automation packages that exist right now for this kind of data. And so we're going to do some talking about that. Today's presentation will take about 20-25 minutes. And then we'll have questions as well. If you have questions, you can post those to me at any point. You've got a control panel that's got a Q&A section, and you can use that to send questions to me, and I'll take a look at those at the end of the presentation. We'll go through them, and I promise if I don't answer your question on the air here, I'll do it privately by way of email or a follow-up phone call. So we'll get to everything. So away we go. Okay, we'll start out. So for those of you that are not familiar with FlowWorks, we are a software as a service, also known as a SaaS, for water and wastewater infrastructure. And, our solutions are around data collection, management, cloud storage, custom dashboards, event notification, alarms, and now we're doing more in the area of event forecasting and machine learning solutions. We've been around for well over a decade, mostly used by governments, municipalities, utilities, agencies, things of that nature, and of course, engineering firms. And for those of you that are paying attention to big data and the Internet of Things and all the great things that are happening out in the world today, you know that there's a lot of data flying around. At FlowWorks, we are currently managing over 25 billion, with a B, 25 billion data points every day. And that's growing at a very fast rate. It was less than half that when I started the company, or started with the company 3 years ago. Really quick, mention cloud storage. We are a cloud solution. We went to the cloud a couple of years ago, and we use Microsoft Azure, which is one of the premier cloud solutions that are out there. And just really quickly, some of the reasons that we chose Azure were security. They've got a level 5 Department of Defense certification across the platform. Reliability with 19 regions around the world, and a 99.95% availability of data. And more importantly to me, and probably to everybody on this call that's used services like this, is scalability. The great thing about using the cloud is that no matter how many customers we have and no matter how many are using it at any given time, we can support 100, 1,000, or 1,000,000 customers without any degradation in the experience. And that's a very big deal, especially with the type of growth that we're seeing. Now, we're here to talk about infiltration and inflow. And I'm not going to go through these basics because I think everybody on this call today already knows this, but this is just a slide talking about infiltration inflow and the fact that, excessive inflow and infiltration results in sewer backups, system overflows, risks to health, damage to the environment, increased costs, so on and so forth. It's wet weather causes problems in many communities, and reduction and understanding of I&I is very important. So I think everybody on the call here today have been or will be involved in what we call an I&I study. And a typical I&I study looks something like this. You deploy flow meters and rain gauges, you monitor for 3 to 6 months, you pray for rain, and then eventually you remove the monitors, evaluate the data, and create some kind of report. And one thing that we know is that takes a lot of time, and you can also expect delays. And I've been involved in I&I studies again for most of my career, usually as an equipment supplier, again with Marsh McBurney and Hawk flow meters. Now, we have, and for those of you that are familiar with FlowWorks, we have a tool for I&I analysis, and it's been there for several years. It went through a big upgrade about 2 years ago. And just really quickly, I'm going to step you through with Trent's help, just some of the process that people need to go through, whether they're using the I&I tool that exists within FlowWorks, or you're using a different tool, one that's homegrown or from another supplier. Trent, just really quickly, I'm going to just go through some quick screenshots, and you can give me some narrative around them.
Yeah, so here's the creating the project page to get started. Once you have that, you specify the flow and rainfall sites you want to include. Then you get taken to the product dashboard, or the I&I dashboard, where you go to create dry weather patterns.
Okay.
As you can see here, this is showing the current, everything that's associated with the project, the patterns, the storm event groups, and the correlations. Again, this is kind of going through fine-tuning the dry weather pattern. You can exclude days, maybe weekends if you want to keep the typical diurnal pattern. Here's a preview of the dry weather pattern, so it's showing you the week. As you drill down, it shows all the Tuesdays within that date range, the red line being the average. And then once you go through that dry weather pattern, now you're in the storm event groups, where you go through creating these parameters. Then our system will provide all the storms that meet those parameters. And then the last part is creating the correlation between the dry weather pattern and storm event groups. The nice I&I envelope that you get as well with that final process.
Awesome. All right, great. Thanks for that. So our question was, when we were looking at automation and machine learning and making the investments here, is that what areas could we concentrate on? And so we asked ourselves, what if you could automate all or most of what we just showed you there? And so it's a really powerful tool, and it's one of the most widely used tools in the FlowWorks suite of tools, and people are using it basically every day. But we looked at it as a kind of some low-hanging fruit where we could apply machine learning, advanced analytics, and automation to make everybody's life a lot easier and actually make this more of a real-time ongoing thing. And so we decided to apply machine learning to that. And just show you this quick diagram right here. This is a sort of a simple look at what machine learning can look like, what the flow chart looks like. And generally, and I'll talk a little bit about it here as it relates to infiltration and inflow and flow monitoring and rainfall data, is that when you're doing a machine learning solution, you start with something called training data. So in the case of Infinitii I&I, that's the available historic data that's out there from a community. And so that's generally going to be rainfall data, so all the different storms that have taken place, and the flow metering data that's been collected over months or years. And basically what we do is we take that training data and we train the machine learning algorithm, and that's something that's done by our data science team, very skilled group of people, and of course our what we call our machine learning engine. And then that creates this dynamic model. All right, and so from the day that the day that we start and we have this dynamic model in place, you start to deal with input data, and that's all of your new data. So this is the new flow meter data that's coming in since we built the dynamic model, and this is the new rainfall data that comes in on an ongoing basis. So imagine if your community or your client was going to start using Infinitii I&I on October 1st. All right, all the data prior to that is the training data, and then all of the data after we turn it on is the input data. All right, but what's neat about this is that the input data comes in and it actually becomes part of the training data. And this is what makes machine learning so special, is as the data comes in, it is evaluated either in a supervisory mode or an automated mode or a hybrid mode, which is both of those things. And then the new data goes back in to help train and make the dynamic model, make the algorithm smarter. And this just goes on and on and on. And as the days and the weeks and the months and the years go by, the system actually gets smarter. And again, if something's getting smarter, it's learning. And this is where one of the reasons that we call it machine learning. So a couple of things about Infinitii I&I, and we're going to get to an example of it here very quickly, is that it's GIS based. It uses both historic and ongoing monitoring data. So that's your flow and your rain data. And our machine learning engine evaluates the data and automatically determines the dry weather patterns that exist within a system, identifies the meaningful storms that have occurred in the past, calculates rainfall-derived infiltration and rainfall-derived inflow, so your RDII, and automatically calculates the envelope or the correlations between peak flow and storm intensity. Now, this is part of the slide deck, but we are going to go to live data here. And this is a live pilot installation of Infinitii I&I, and I'm going to refresh it to make sure that I'm still logged in here. So thanks for your patience. And so one of our clients, we've got several pilots running in North America right now, several in Canada and several more in the United States. But one of our clients has a sewer shed, watershed that is outlined here with all of these different basins, and they happen to have flow meters in all of them, and all of their data has been coming into FlowWorks for quite some time now. And what we've done is we've piloted Infinitii I&I, or we're continuing to pilot it in the basins that you see that are colored right here. Right, and so what's happening is that we've taken in data, as you can see here from the left, we've taken data as far back as 2013. And once we've brought that data in, we've characterized all the things that I've already talked about. So your dry weather, your storms, and then the I&I, and then some statistics that I'm going to show you right here. But so on this particular map, and for a particular storm, so the most recent significant storm that this client has had was July 11th of this year, so really not that long ago. And we've got several metrics that you'll see down here that are automatically calculated. And the first one is RDII volume by catchment area, or gallons per acre, RDII volume by pipe length, gallons per linear foot, RDII flow by pipe area, that's MGD per inch mile, and peak flow by area, MGD per acre, and then the percentage of rain captured. Now, we've got quite a few Canadians and some Europeans on this call, and all of these statistics have duplicate versions that are in metric. So just know that that's a thing. But as you'll see, for this one particular metric, we've got this dashboard, and we have a legend here that is basically collaborated on with our client so that we know what the thresholds are for their particular needs. And for this first metric right here, you can see that if we go to different storms, the map will change, okay? So it was green for that one particular storm, but you have this one catchment that was actually red for RDI volume by catchment area. Now, if you were to change metrics, you'll also see that the colors may change. In that case, that one was orange. If I go to RDI flow by pipe area, this catchment happens to be yellow for this particular one, and I'll just switch to another storm just to see if and as you can see, for each different storm, we can see what the wet weather response was. And this is just a nice at a glance idea of what the wet weather response was for any particular storm. What's particularly nice about this is that if the storm had taken place, let's say yesterday, you would have these statistics the next morning. And so you would be able to open up your Infinitii I&I application and have a really good idea of what the wet weather response was to yesterday's storm across the entire sewer shed here. So again, if this was at full scale, every one of these catchments would be colored and they would be updating instantaneously. All right, so you can see down here, we've got the, for each one of the catchments, we've got statistics like the area, the pipe length, the pipe area, and then for each particular storm, we've got more detailed statistics. Now where the fun begins is when we can sort of drill down a little bit deeper here. So let me go, let's pick this one. This was last Thanksgiving, and let's pick PA06, which is located right here in the center, and I can click through and open up some details associated with this. So again, the first screen that I was showing you, this is just a nice dashboard. It's a good visual. It's got broad appeal for people so that you can just get a quick idea of what everything looks like and visually see what the wet weather response was. Now, what happens though is that when we drill down into a particular catchment area, Infinitii I&I automatically selects the 15 most significant storms and then has them listed over here on the left. And these are sortable. They happen to, you can see by this little arrow here, they auto sort to the 6-hour maximum rainfall. Okay, so this one here at the top had a 6-hour maximum rainfall of 1.68 inches, so it comes here to the top. But if I click on any of these headers, I can change the sort based on the start of the storms, the end of the storms, or the peak 1-hour average RDII flow. Or so I can come right back to this again. Now, what we see here, this is super powerful. You can see for this one particular storm here at the top, what we've done is that the yellow line that you see here, this is the automatically generated, machine learning generated dry weather pattern. Okay, so using our machine learning, we go and look at all the days for all the historic data, the time of year, day of the week, month, etc., and figure out what the dry weather pattern should be. And you get this really nice pattern here. Now, the red represents the actual flow. And of course, rainfall is indicated here by the blue lines that are descending from the top. We're identifying, just visually identifying the storm with some, by bracketing here in gray lines, right? Okay, so you've got dry weather, your actual flow. You can see it starts raining and you start to get a divergence between the actual flow and what the dry weather pattern is. And that, of course, is your RDII, which we indicate down here in this kind of dark bluish green line, with the peak RDII 1-hour average indicated here with this circle. Okay, so let's switch to a different storm. And it takes a few seconds, but the interesting thing here is that this is all being calculated as we speak, or as I'm presenting it here. So this has not been calculated and cached in the background, right? This is always being recalculated in case there's been some changes to the data. So it's possible that maybe through the use of this tool or other FlowWorks tools that you determine that there's some data that need to be repaired. And you go back and you do that. This system anticipates that happens from time to time, and so instead of calculating and caching the results, it auto calculates them. So again, something that would take hours, I mean hours of a data analyst and or an engineer being involved in this full time, is done in a matter of seconds. Okay, so for this particular storm, looks a little bit different, but again, you've got your dry weather flow here in yellow. And you've got the red represents the actual flow, which starts to peak after the rainfall. And then you've got your little I&I peak here. I'll go to one more storm, just again, so you can see how these look. There we go. And, a little bit different. This storm is different. And, we capture all of that. So all of that is there. And now you've also got the ability to, for this particular catchment, look at the correlations, also known as the envelope here. And so we've got a best fit curve here, against the return storms here. And in this particular case, they're kind of clustered here. We've also got this, excuse me, basically the outlier, the best fit to max flow here on the top. So you've got this one storm here. And actually, if you wanted to take a look at that particular storm, you can click on any of these. And it takes us to that particular storm, so we can sort of get an idea of what it looked like. Why was that one a bit of an outlier? Now, go back here to the envelope again. Now, everything that I'm showing you is very, very powerful automation, and lots of people like that. However, there are times when you look at your data and you think you as an engineer or an analyst might look at this data and say, you know what, there's some storms here that if I was doing this, I probably would not have included them. Or there's some storms that I expected to see here that that didn't show up. And so what we've done is that we've made it possible to export the data from Infinitii I&I. So all the calculations, all the hard work have already been done, and you can export that. And I'm going to turn this over to Trent really quickly. Trent, you can show us how that works.
Yep. Make sure you can see my screen all right.
Yep.
Perfect. So yeah, let me go ahead and I'll just kind of get that process started of where you click on the export and it'll just start churning for us. I have a project open that I'll reference just for time's sake, but real quick here, just get this pulled up. So once you click the convert to manual I&I, it's going to give you this notification here. It's retrieving the data. And then once it's done populating, it'll open a new tab and take you to this dashboard of a project or of the project we were just looking at within the Infinitii tool. And so as we showed in the screenshots before, you're able to create dry weather patterns if you want to make additional dry weather patterns or modify any of these. You're able to create storm event groups to add to the one storm event group that we currently have. But if you want, we can just open and quickly take a look. And so with this, you'll see it shows the weekly dry weather pattern that we have exported. We can go day by day and review it. And then you're also, let me get this out of the way here. You're able to, if you'd like, create the new ones like we talked about. And so if you want to go ahead and go through any specific date range, any specific day exclusions, you'd be able to do that as well. And so, like Kevin said, this has been a really nice feature for us to bring to the table because it really brings it full circle. So now our clients that, like you said, if there's any potential hesitance on what they're seeing, wanting to add additional storms or change something, you'd be able to do so within the manual tool.
Great. Excellent. Thank you, Trent. I'm going to take back controls
here. Yeah, I think
here.
You can take it back. Perfect.
Right, and I think this is where I left you guys off. Yeah, so just really quickly, just to show you maybe something else, we'll go to one of these basins out here. This is an interesting one that just wanted to bring to everybody's attention. Just to show you some of the capabilities of Infinitii and how smart it actually is, because from time to time you get into situations where you've got some interesting flow characteristics, and this happens to be a site, and I know this from talking to our client, because the first time we saw this we were like, oh well, we should ask some questions about this. But you can see you've got a very interesting dry weather pattern and a very interesting actual flow rate, but this is heavily influenced by a lift station, and which is why you're seeing this. You're seeing this up and down motion of it going. Point of me showing this to you, though, is that Infinitii I&I is smart enough to figure that out. It understands what it's saying, doesn't get confused by it, and still does a very, very good job of determining, calculating RDII, for this particular site. I mean, here, another storm, you can just see just all this activity. Interesting storm here, pretty big storm. And again, you've got your dry weather pattern, your actual flow rate, and your RDI here, your peak here, of course, all of your rain here. Anyway, so we're very, very proud of this. This is it's a terrific tool, and one that I hope everybody on the call here will be using eventually. So let me get past the slide deck. That's everything that I was going to show you, from the live version of it. But just as a reminder, the KPIs and the metrics that we have here are RDII volume by catchment area, RDII volume by pipe length, RDII flow by pipe area, peak flow by catchment area, and percentage of rain captured. And again, all of this, our Infinitii I&I clients get all of this auto-calculated for all the historic data that they bring to us. And then this is auto-calculated in near real time for every storm going forward. So you can have all of these metrics and you can have a nice visual idea of the wet weather response of your collection system within 24 hours of a significant storm. And that's really, really powerful stuff. Just some benefits, if they're not obvious to you, is you get to make use of this historic flow and rain data. A lot of people on this call are sitting on years and years of data that might have been used for some single purpose. And this gives you an opportunity to get some value out of that data. Again, imagine taking all of that data and understanding the wet weather response of your collection system for all the significant storms you've had over the last 3 years, or maybe the last 5 years. You get that automatically. So you get this great look in the rearview mirror and understand what's happened in the past, and you get this near real-time idea of the wet weather response of your system going forward. You wind up with fewer assumptions between studies. I mean, this is usually what happens is that people do an I&I study, and they basically assume that this is the way that the collection system is going to respond for the next 3 years, 5 years, could be even worse, 10 years. This takes those assumptions out of that. Recognizing changes in wet weather response, right? I mean, so there's climate change. I like to refer to it as climate uncertainty. Almost everybody that I talk to tells me that they can no longer assume that rainfall intensity and duration and frequency and time of year is happening the same way that it did when they grew up, or even in the early parts of their career. Okay, so it's good to have a system that's always learning and understanding as things change. Parts of your system may be aging differently, and so this is another way to start taking some of the assumptions out of it. And you get to use real-time results to help inform immediate and long-term decisions, right? And so the results that you get today can help you decide that you're going to do a more intensive I&I study in a particular part of the collection system, right? Or it could be the type of thing that you collaborate with your consulting engineer on to try to figure out how to mitigate issues that exist in certain parts of your system. Helps you narrow down where you need to spend your time, and maybe more importantly, where you spend your money. Also gives you an opportunity to anticipate flooding, overflows, things of that nature. And what are we, about 25 minutes into it? We are basically at a point where I can take questions. So what I'm going to do, as I've already mentioned, I'm going to open up the question panel here. And we've got a lot of questions. That's a good thing. Let's see, I'm sorry, just give me a second so I can read these. Okay, well, a common question is that are the PowerPoint slides going to be available afterwards? And so, yes, I can make the PowerPoint slides available to anybody that asks for them. I'll send them to you via email. And so just let me know. I've got a couple of people that have asked already. You've got my email address as part of the reminders that have been sent out to you for this. Just feel free to respond to that if you would like to have these slides, and I will bundle them up for you and move them your way. I'm also going to, I'm recording this, and so you can have the slides and the associated audio. That'll be available in about an hour, and you'll get a notification from us when that's available. It'll be part of a thank you message that we send out. So look for that. And if that's the kind of thing that you want to share with others in your organization, it's a very popular thing to do. Can the software recognize holidays with dates that change from year to year? We've observed daily diurnal patterns are influenced by calendar days. And yeah, that's a really good question. And yes, the machine learning is certainly capable of that. And what it comes down to is it comes down to having lots of data. So we don't explicitly need to tell the engine or the algorithm that the holidays exist. It basically determines that there are certain days, and based on time of year, day of week, etc., where you can expect changes to take place. And so, but it does require data. The more data you have, the more it understands that. Now, that being said, if it was significant enough and something you wanted to get ahead of, we could bake certain dates, certain times of year, differences in there as part of the training of the algorithm for specific clients. And so that could be addressed in a number of ways. One, automatically by just counting on more and more data, or by doing that in the learning and training mode. Please maximize the screen. I guess that's too late for me to do that. Sorry about that. A good industry friend of mine who I'll see at WEFTech in a couple of weeks, by the way, while I'm looking at questions. WEFTech is in Chicago this year. We will be exhibiting as we always do. So if anybody on this call is going to be at WEFTech, please come by our booth. We'd love to meet you, and we'll be showing Infinitii I&I as well as some of our other basic and machine learning based solutions. Okay, what do we have here? How does machine learning deal with system growth? We're growing rapidly each year. Can you feed a constructed storm as a test case and feed into the software, and then see a predicted response as a flood management tool, for example? How does poor data influence machine learning? Are the thresholds set to discount poor data? Okay, kind of a lot there. So how does it, first thing, on a growing system or a changing system? So it's a really good question, and machine learning is about a couple of things. One of the things it's very much about is data. It absolutely needs data, and it can learn from data. And so if your system has monitors on it, and as you grow, if you're adding flow meters and you've got rain gauges that are associated with that, over time, it will get smarter and smarter and understand what the effects are on your system. So you will be able to do a good job of understanding the wet weather response, even in your growth areas. But you have to understand as well that that's something that it will actually take time for it to get better and better. So in that sense, it's really not a lot different than a human, but a human that never stops working and has perfect memory, right? And so if you've got a growing system and you have a team of engineers and data analysts and technicians that are responsible for understanding what's happening in the new parts of your system and how that's affecting the wet weather response of your entire system, they're only going to get that from data analysis and a lot of hard number crunching and engineering. Here's a system that just absolutely automates that and makes it more reliable even as your staff changes. All right, so if you're growing, you're also getting new staff in, you're probably rotating staff out, people are moving up into new positions, and you might be losing some institutional knowledge. A system like this, the institutional knowledge becomes part of the Infinitii I&I system, and you never lose it. And again, it keeps getting smarter and smarter. So yes, theoretically, we could feed a constructed storm in here, and I shouldn't even say theoretically. It's the way our channels work is that you could create a storm through basic FlowWorks, feed it into Infinitii I&I, and see what the response is going to be. So yes, that would absolutely be something you could do. Poor data, and yes, absolutely. So a couple of ways of looking at data is that poor data is going to create poor results. However, we have an anomaly detection and resolution tool that runs in the background, and also via machine learning looks at and finds outliers that are clearly not representative of what's actually happening in the system, and makes appropriate adjustments to bring the data in line. Now, that's is going to come into use if you're using just raw data and not correcting that data as you go. So different people approach this different ways. A number of our clients have the channel that we use Infinitii I&I against is their Q final channel, and so we calculate based on that. If we're calculating on Q final, however, we can only calculate as quickly as Q final is generated. So if it takes you days or a week or a month to have a Q final channel, that's the most recent Infinitii I&I data will be based on that. Now, our machine learning anomaly detection and resolution engine is actually quite robust, and it actually gets better because it's based on machine learning. It's getting smarter and smarter every day, and highly recommend anybody that's interested in seeing how it performs is to do a pilot with us and a number of any number of sites, somewhere between 5 and 10 sites that you might have in your system, and you can actually see what a good job it can do even on raw data. Okay, let's see, a couple more, a couple of people asking for slides. Bear with me, I just have to scroll through the questions here. Okay, a couple new ones have just come in. So do we see this as something that is going to replace traditional I&I studies? And the short answer to that is no. I think that there's always going to be a place for these intensive I&I studies. I think what this does is it gives you information immediately after a storm that can help you maybe understand a little bit more quickly where you want to do a more intensive I&I study. So yeah, another question here has to do with our metrics, and let me just back up to those really quickly. You'll remember that I was showing you the metrics here. These are the standard metrics that come with the system. However, if you've got some metrics that are different than this, but that are important for you understanding the wet weather response of your collection system, we're happy to incorporate those into Infinitii I&I as well, as long as they're just something that's calculable with the data that we've already got in hand. Okay, so that's certainly something that we can do. Trent, I kind of ignoring you and your ability to look at questions. You see anything out there?
So yeah, I think the one I saw was about forecasting, just some of the forecasting tools that we have as well. So it wasn't on the Infinitii I&I stuff.
Okay,
It was about potentially forecasting. So yeah.
Okay, I'm going to get to that in just a second, and I'm going to move this along pretty quickly. Another question here is that does it matter what types of flow meters that we're using in our system? And the answer to that is no, it does not. We are hardware agnostic. We don't really care where the data comes from. In fact, you can send data to us from any number of flow meters, and we normalize it at FlowWorks, and then we present it so that it basically looks the same and can be used in a tool like this. In fact, any of the major manufacturers of flow meters out there, rain gauges, we've probably already got automatic integrations with them, so we can very easily bring their data in. And we can also bring data in from SCADA systems. We're doing that more and more. We can a lot of that's being done through what's called an API. And another thing that people are starting to find good use of data from their lift stations. If you've got a lot of lift stations, think about places like Florida, for instance, where there's an awful lot of lift stations, Texas, sometimes the coastal areas of the Carolinas. A lot of people have got good flow data coming from those lift stations that are not being used for anything except understanding pump performance. Well, what if you could use that data to automatically bring more data into a system that tells you what your wet weather response is of your collection system? That's absolutely something that you can do. Okay, I've got somebody talking about having close to 100 lift stations. And there's a question here about bringing data in from Contrail / OneRain, so providers of radar rain data. And yes, absolutely, we can do that. We've have both informal and formal communication with a number of those companies. Most of them are able to turn their data into basically virtual rain gauge data, which is the way we would bring it in so that it looks like rain gauge data to the system. And we would absolutely be able to do that. Let's see, somebody joined late. Did you already mention if Infinitii is an extra cost? Yeah, okay, so yes, if you're using FlowWorks, you know that FlowWorks pricing is pretty straightforward. It costs $30 per site per month, and you get a really great deal of tools that come with that. Infinitii I&I is something that rides on top of that, and it's so there'd be an annual cost associated with running Infinitii I&I on top of your current FlowWorks. And because the question is going to be out there, I'll talk about that. I will say that the price is going to have a lot to do with the complexity of the system, number of sites, et cetera, et cetera. But I think at the low end, what we're seeing with the proposals that we've got out there for smaller, simpler systems, we're seeing prices of around $35,000 to $50,000 a year, $35,000 to $50,000 a year. And then we have proposals out for some more complicated and complex systems that are north of $150,000 a year. So, you know, we're not talking about a $500,000 or $1 million, but we're also not talking about $10,000. But again, think about everything that you're getting here. I mean, this is, as far as I'm concerned, everything that I've seen when it comes to technology and automation out there, this is the type of thing that is going to save you hundreds of thousands of dollars a year, both from a manpower standpoint and also just having information that you can actually act on. Now, Trent, I promised that we would talk really quickly. You mentioned something about forecasting. So one of the neat things that we're doing is we're building other machine learning based systems, and forecasting is a big one. We've had a CSO, a combined sewer overflow forecaster, in place for some time now. Actually, I can go live there. And this is a live, you can see the current date here and the dates going forward. This is a Infinitii CSO forecaster, which is all machine learning based. And it tells this particular client, you know, up to 7 days in advance whether we think they're going to have any overflows within their system. We're also applying this to more general purpose flow forecasting. If you've got places in your collection system where you would be interested in knowing what the flows are going to be, you know, at a specific date and time in the future. So maybe 2 days from now, you know, when you might have a peak flow related to a storm event. We are building those on a pilot basis right now for our clients. So think about at the treatment plant, you might want to know what the flows are expected to be, you know, days in advance at the treatment plant, which your peak flow is expected to be over the course of the next 24, 48, 72 hours. We can do that. And we can do that very well. So keep that in mind. That's something we'd love to talk to everybody about, or talk to individuals about. Oh, one last question is in. I can show you this. There was a question about rain gauges and the availability of rain data. So while a lot of people might have rain gauges that they own, also know that we can bring data in from lots of different sources, including public sources. And so this is a map that happens to have an overlay on it of all the USGS gauging stations that are out there. Now, a lot of these include rainfall data. And so we can very easily bring in rainfall data where it's available from the USGS. We can also bring it in from the National Weather Service. There's also stream gauge data here that some of our clients find very useful in understanding other things that are going on within their system. And that's also data that we can bring in for other machine learning type purposes. And that could even help inform, you know, flow forecasting and flood forecasting, depending on what we're trying to understand. Okay, let me do one last look at questions that may have come in. I think we've exhausted them all. Yeah, I'd really like to thank everybody. You've been a great audience today. This is one of the largest audiences that we've had since we started doing webinars on Infinitii I&I. Trent, I'd like to thank you for all your help. I couldn't do it without you.
Yeah, no, thank you, Kevin. This was great.
Yeah, and again, folks, if you're going to be at WEFTech, you know, reach out to us. We'd love to see you. And also, if you would like to have copies of the slide deck, some of you have already told me that in the Q&A, but send me an email and I'll get those out to you. If you'd like to be part of a pilot, please let us know. They're very easy to get into, very low or no cost, and we're pretty sure you're going to be impressed with what you have to see. All right, bye now. Have a great day.